We shall now look at 1 to 4 demultiplexer. In our definition for the demultiplexer, unlike the multiplexer, a demultiplexer will only have one input data line, and when passing through a demultiplexer can now be able to pass through any of the multiple output data line. And this demultiplexer is important in many applications in digital electronics, and learning this will give you a better idea into looking at how you can send especially a digital data into a multiplexer, so you can select whatever the destination of the data that you want to send. As an example, we can see that a demultiplexer is nothing but a route. Let's say we are sending a letter through a mail, and this demultiplexer can act as a postal service, and this mail can be sent to multiple locations such as location 1, location 2, location 3, location 4, and we have the location 5. And we have nothing but what is called the select lines, and this particular select line can act as a address to each of these locations. Therefore, we normally have a select lines in a demultiplexer similar to the multiplexer that we have discussed. So depend on the select line, this mail or information containing a data can be selected to go through each of these locations. That is why when sending a data in a communication system, it is mostly important that we identify the address and the data that is need to be transmitted through a particular location in a digital system. Now we will look at the symbol, the truth table, the logic diagram of a 1 to 4 demultiplexer. Now let us begin by looking at the symbol for the 1 to 4 demultiplexer. We can have 1 to 4 DEMUX, and DEMUX represent the demultiplexer circuit. And we can have the D, let's say D represent the data, and we have 4 output such as Q0, Q1, Q2, and we have the Q3. The Q0, Q1, Q2, and Q3, they can be regarded as a channel to a specific digital system. And we have the data, that means it represents the information that needs to be transmitted to each of these data line Q0, Q1, Q2, and Q3. And in this case, we can see that we have one data line which is the input, and we also have 2 select lines, and we can have S0 and S1, and we now have 4 outputs, and these represent our symbol for the 1 to 4 demultiplexer. I will also explain how this is similar to a decoder circuit where we have 2 to 4 decoder. However, the circuit configuration is the same, however the operation is different. And remember that sometimes this symbol can be drawn in this manner, where we have 1 input and 4 output, and we have S0 and S1, and this is the same circuit, however the symbol is drawn differently. Now, since we understand the symbol, we are now going to look at the logic circuit diagram. I will now draw the logic diagram of 1 to 4 demultiplexer circuit. And now this is our logic circuit diagram for 1 to 4 demultiplexer. And remember from our discussion, for the 2 to 4 decoder, in this 2 to 4 decoder, we have 2 input and we have the 4 outputs, where 2 to the number of 2 input will give us 4 output combination, and we mostly have 1 enable. And this can be seen from this circuit diagram, where from this 2 to 4 decoder, we normally have this 1 enable if we are to provide a description for 1 to 4 DEMUX, and we do a comparison. We can see that for this case, we now have 2 select lines, and this one we have the 4 outputs, and in this case we have 1 enable, and in this 1 to 4 decoder we now have a data line. And these are the difference that can be found, that sometimes this 1 to 4 decoder can act as 2 to 4 decoder, and these select lines can now act as an input. If we apply some input data to the select lines, now it can act as a 2 to 4 decoder. But the difference is that the data lines which carry data in 1 to 4 demultiplexer will only act as an able in a 2 to 4 decoder. And if you compare the circuit diagram, you can see clearly. However, 1 to 4 demultiplexer, this type of enable can be used as a data line, where this data line is responsible for carrying the information, and this information can mostly be in terms of a serial data, where data is passing through the data line one at a time. And we can now be able to compare the truth table, and we can see how those two are the same, but in terms of the application wise, it is different. 1 to 4 multiplexer has a different operation, and 2 to 4 decoder also have a different operation. Now I will draw the truth table for 1 to 4 demultiplexer. And from this truth table, we can now be able to see that it is the same as what we have discussed using the 2 to 4 decoder, where when we have the 2 select line S0 and S1 is equals to 0, that means this data available at the data line as an input will now be passed through Q0, which can be seen as, let's say, location 1. And when we control the select lines by applying S0 equals 1 and S1 is equals to 0, now this data, or the same data at the input, will now be able to pass through Q1, which can be seen as a location 2. And we know that by selecting the S0 equals to 0 and S1 equals to 1, now we are making the data available at the data line Q0, or we can say the location 3. And finally, when both the select line we apply 1 and 1, we now should have the data passing through, let's say, location 4, or the data line 4 of the output of the 1 to 4 demultiplexer. And we can prove that if this data is a serial data, that means we have a data that can be something like this. We can have 0 1 0 1 0 0 1 0 1, and this is the serial data that will pass through the input of the 1 to 4 demultiplexer. And if this information carries the word, for example, hello, now where can we send this hello? If we want to send this hello to location 1, now we have to apply 0 and 0 bit at the select line. Now we know that automatically for the AND gate, the output is always high only when all the input is high, else the output will be low. Now we can see that we can have 0, 0, then when it is inverted, this will becomes 1 and this will becomes 1. And since this data is available at the input, we now will say this is 1, so this data will be passing through. And imagine if we send this data, now we can have the most significant bit to the least significant bit. So we are going to look at the data that is from this end, from the right end towards the left end. And if we want to pass this data through this particular AND gate, so when this is 1 from this particular segment, now at the output we can have Q0, it will also register a high. And the second bit that will pass through this AND gate will be 0. And this will be 0, and when 1, 1 and 0, it will register a low. And then the next will be 1. So when this one is 1, we have 1, 1 and 1, the output will be 1 again. And then we can have 0, it will register 0 at the output, and if we had another 0, then it will register another 0, and now we have this 1 passing through, we can have 1, and then when we have 0, the output will be 0. When we have 1, which is here, we will have another high, and we will have low. So you can also see that we have D, which is the data coming in, and if the select line is 0 and 0, we now should have the Q0, which is given here, which is the output, where you will see that it will register the same value, which is the 0, 1, 0, 1, 0, 0, 1, 0, 1. Now we can see that this data is transmitted successfully to location 1. So you can see that this location 1 is the Q0. So you can do the same for all of these to prove that the data that is available here, D at the Q0, which is the same as the input. So with these select lines, we are now selecting the location of output of the demultiplexer. So by carefully selecting the select line, we can specify the output of the demultiplexer to pass the data which is coming as an input. And I believe with this example, you can be able to really understand what is a demultiplexer, and with our discussion for 1 to 4 demultiplexer, we can be able to see that if we are passing data to 1 to 4 demultiplexer, we can see that the select lines plays an important role, because upon selecting the select line, we are now controlling the data that will be transmitted to which of the output channel or the location of the demultiplexer. And we also see a comparison between the 1 to 4 demultiplexer and 2 to 4 decoder, and what are the parameters that makes them similar. However, the application is quite different. And similar as our discussion in the decoder, now when the select line is 0 and 0, that means it will still accept the data from the input. If we want to have a control such that this particular 1 to 4 decoder will be enabled or disabled, that means if we disable this 1 to 4 demultiplexer, that means even though there is data at the input and the two select line is 0, 0, then the data must not appear at the Q0, which is the output, because we want to have some control. Because by disabling the circuit, although there is a data available at the input and we have the select line configured, now data cannot be transmitted unless we want the data to be transmitted. Now we will enable the 1 to 4 demultiplexer, because for all the combination of the select lines, it will choose either one of the output to pass the input data. We can simply connect another input to each of this AND gate to make it becomes a controller for enabling and disabling the 1 to 4 demultiplexer circuit. And now we will just connect an external input such that it is now the EN, which represent the enable, and this enable must be connected to all of these AND gate. When the enable is 1, that means it is now activating this demultiplexer so that all the gate will be in operation. And when this is 0, when we apply 0 to the enable, now we are disabling all the output. So whether we have any input at the data line, and if the select line is selected for 0, 0, 0, 1, 1, 0 and 1, 1, it doesn't care because the control now is on the enable. If we want to allow the data from the input to pass through any of these output, we have to enable the circuit. Else, we have to disabling the circuit by applying a logic 0 at the enable pin. And also, we can modify the truth table such that now we have another column which is the enable. And this enable with EN, and we can have another more row, and by then if we have the data, if the enable is 1, then this data will be available at each of these output. However, when the enable is 0, then we don't care about the data and we don't care about the select line. The output, all of them will be 0, because when we apply 0 to each of these AND gate, that means all of the output will be 0. So this can be our finalized circuit, and if you want to use in your application, it is better you will select a 1 to 4 decoder with enable. By controlling the enable pins and the select line, you will now efficiently send the data from the input data line to one of the output of the demultiplexer. And I believe with this explanation, you can now be able to fully understand what is a 1 to 4 decoder and why is it important in terms of its symbol, the circuit diagram, and the truth table. Not the least, we have to discuss the Boolean expression for this 1 to 4 demultiplexer, and we can sum up our discussion. By looking at the truth table and the circuit diagram, we now can be able to select the Q node such that when we have the S0 and S1, which must be inverted, and we have the data dot enable, then we should have Q1 which is activated. So this can be the expression, and when we have Q1, we can be able to see that we can have S node and we have S1 inverted and the data line and the enable. So as Q2, we can have S0 inverted, S1, D and the enable, and we have Q3 which will be equals to S0, S1, D, and we have the enable. So this will be our expression for 1 to 4 demultiplexer. And remember that the enable will be the control such that if it is 1, now all this will be effectively receiving the data. If the enable is 0, that means they won't be able to accept the data, or data cannot be flow at each of these output. Thank you for watching our video. Kindly subscribe to our channel and share this video with your friends so they can also be able to learn.